so anti Miss Price.
Today we are starting section 7.2. We're going to be in section 7.2 for the next several days. 7.2 is all about volume. Today and tomorrow we're going to learn how to find volume by revolution. These are shapes that are formed by revolving something about an axis. I have here a bottle of peach blackberry water that has been sitting on my desk for 3 months, I guess. I don't know. Anyway, yeah, for a while. Now, if you look carefully, if you take this bottle and say we turn it sideways and say we took a stick and stuck it right through the center, right, and it came out the other end, and that was like right dead center in the bottle, right? If we were to take the edge of the bottle and trace it, and we had some function that modeled this shape, the outline of the bottle, we could take that function and revolve it about that axis, and that revolution of that function would actually create the bottle. So, and if you look carefully, like you take this like first part, you revolve it about the axis, you get this circle, right? Any shape that is formed by revolution, the cross section anywhere in the shape will always be a circle, right? So you slice it, if the cross section of a shape is always circular, it's probably a shape that can be formed by revolving about an axis, all right? So those are the types of shapes that we're going to learn how to find the volume of today, right? Oh, here's another one. Here, I could use the cup. All right, so I got a solo cup, right? Same kind of thing, right? Stick a line through the center, just nice, like slightly diagonal line here, revolve it about that line, and you get the shape of the cup, right? You can turn it this way vertically, right? Still works, just a vertical axis of revolution, all right? So we will be doing that today, and the first thing I'm going to show you is this little applet. I love these applets. There's a website that's just full of calculus applets.
Calculusapplets.com.
It actually might be. It might be. Look, see? There's the title. It could be. So they have applets on everything. If you ever want to explore, quiet please, the topics you've learned. Here, let's see. I messed it up. Yeah. So like, if you ever want to explore this website, Calculus Applets has like a million applets on all kinds of different things. But
oh, let's do Riemann sums.
Riemann sums we did, remember in class? And
oh.
We changed the
let's
rectangles.
Do Euler's method.
So
yeah, let's do Euler's method.
Euler's method.
Euler. Okay, we're going to do volumes of revolution.
Alright, fine.
Okay. Alright, so here's our first shape. This is just the axis is the x-axis, and this is just the line y equals 2, and it's revolving about the x-axis. If we slide this value back and forth, you can see that no matter where you are in this region, the shape, the cross-section is exactly the same. It's always the same size circle. What shape would this whole solid be if we were to fill the whole thing?
Cylinder.
This would be a cylinder, right? Okay. So if I change my top function to x squared plus 1, and I am going to, I'll keep that, and I'm going to go -5 to 5, so you can see better. All right. So now I have a shape where the upper function is a curve, and the lower function is the x-axis. And if I slide the shape over, that's what you get. Right? You get this kind of a, like a bullhorn kind of a thing. Right? Something like that. So we had a problem once, there was a problem in an AP exam where they had a gramophone. You guys know what I'm talking about? And we're kind of like an old turntable with a big speaker thing that looked just like this coming out of it, and you had to find the volume of it, like a record player. Right?
With the old-fashioned speaker.
The old-fashioned speaker. So anyway, they did that on the AP exam one year, so you had to find the volume of the gramophone. So same kind of thing. You can have, you don't have to have your axis be 0. We could have our axis be 1, and we would get this shape, right? It'd be just a skinnier kind of a cone with curvy sides, kind of.
Looks like the roof of the Dallas International Airport.
We could do, how about,
Could be on like.
Let's do 1/2 x.
oh, I want to go with 0. Okay. Alright, so if we were to do the square root of 4 minus x squared, that's a semicircle. It doesn't look like a semicircle, but that's just because these axes aren't the same. It's wider than it is tall, but it is. And you fill it in, oh, whoops, I can go -2 to 2. There. And whoop, and you get this kind of a shape, right? Lots of different shapes that you can form just based on the function. So what did you want me to do?
1/2 x.
1/2 x
For no reason whatsoever.
for no reason whatsoever. It just goes
Looks like a boot.
Let's go 0
0
and 4.
to 2,
No,
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 it doesn't.
0 and 4.
0 to 4.
No, sorry. The 0, the axis is 0, and the g of x is 4.
The problem with that is this little applet won't do vertical rotations.
Oh, so
So-
that wouldn't work?
Yeah, that would be tricky.
Lame.
So,
I was just trying to do the problem.
Now, I will tell you, it would be equivalent to doing this one. It'll look the same, just sideways. Woo, a big wide cone, right? So when the sides are flat, like that, you get a geometrical shape, a standard geometrical shape, like a cone or a cylinder.
That's standard?
Why don't
Yeah,
you do
it's
like
a
a
cone.
why don't you do like a sine function?
Ooh. So, ooh, kind of similar
make
to
it go from
the
-2 to
root
3.
function.
So
Yeah,
that
make
would-
it do like a bunch
Make it
of
like
stuff.
sine of x times like tangent x divided
Yeah.
by 7.
Sine x tangent x
Sine
over 7.
plus secant x.
Oh!
Wait, hang on, let's see what does it look like.
Oh, whoa! Go
Yeah,
back.
because it's got to go to infinity, right? Woo! Yeah.
Can we have that shape in real life?
Okay. So anyway,
That's the
all right. So you get
Hey,
the
what does
idea.
that shape look
Now-
like in reality?
Before I switch to doing some examples, I'm just gonna teach from my desk for a minute here. And I'm gonna do a little remember when.
So what the hell?
He was complimenting your belt.
Oh, John Green?
Said it's very
What?
late.
On the, he
Oh,
also has like a
HBO,
YouTube series.
Okay.
I said it was very late.
Okay, so here we go. Remember when
He also has like
when you first learned area and you had some bounds,
I haven't seen them, but I really like it.
and so say we wanted to find the area of this region, right? And let's call this f of x. And if you recall, so we have area would be, how would I write a formula that would give me this area?
You're gonna go from A to B about the back.
Dx. Okay. What does this integral actually represent? Well, if you think back to when we first were learning area, the way that we did it was we did it by splitting the region into rectangles, right? Something like, I'm just going to do
Isn't that like Riemann sums?
that is Riemann sums, right?
That explains why
So
I
we
hate
split the region into rectangles. If you look at your integral, and you want to think of how does this integral relate to finding this area? Well, these rectangles each have an area of width times height, right? And it's from A to B. A to B is kind of simple. What does the integral symbol stand for again?
Sum.
Sum, right? This is an infinite sum from A to B of f of x times dx. F of x is your function value, and it gives the height of the rectangle, right? Dx, if you remember, if they're all equal width, we used to call it delta x back when you were young, right? And how does dx relate to delta x? dx is the limit as delta x approaches 0. So what you're doing is you're making the widths of all of your rectangles approach 0 so that you can fit infinitely many of them in that space, and then you get an exact area, right? So what you get with your integral is, when you're finding area, it's the sum of the areas of all of those rectangles, right? Width times height.
Do calculators
Okay.
like perform integrals just through brute force, or do they know like how to anti?
No, there's a program. They don't anti-differentiate. There's a program for calculating it. All right. Suppose we wanted to take that same shape, but this time we want to revolve it. This is going to look really, really bad.
That's gonna be an interesting looking shape.
Yeah, we're revolving it about the x-axis, right?
What's the base?
So, all right, so we get this like funky. This looks terrible.
It's like an hourglass. Looks more like a flower vase.
It does look kind of like.
I think it looks nice. Just
Oh, well,
not-
thank you, it's lovely, okay. All right, so anyway, so we're gonna split it. So we need to split this shape into geometrical shapes where we can just find the actual volume. So we need a three-dimensional shape that we could use where we know how to find the volume. And it has to be a shape where it's round down the edges, circular.
Sphere.
Sphere.
Yes.
Circle.
Cylinder.
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 So
Any
if
cylinder
we
would.
split this shape into a bunch of cylinders, right? If you look carefully,
A great rhyme that sounds again. Just I did not want.
right? And we split the shape into a bunch of cylinders and added them together. What we get then, if we added all the volumes of all the cylinders together, is we would get the volume of the whole piece. And of course, what we would want is the height of the cylinder, which is the width, technically, in this picture, to approach 0. So our volume formula, I'm just going to move over to the board.
Should we write that down?
Probably. I think she's pointing the camera at it.
Okay. Our volume formula, this is called disk method. Does everyone know that a disk is like a flat cylinder,
I mean, have you ever seen a
Oh,
CD?
disc.
I assume so.
right? Oh, yes, compact disc, right, okay. So anyway, a disk is like a flat cylinder. So this method, when you take a three-dimensional shape that has circular cross sections and you break it up into cylinders and then add all the volumes of the cylinders together, that's called volume by disk method. You're using disks to find the volume.
I just thought of the best math joke ever. That would trump your math joke in a second.
Oh, let's hear
Do you want to say it now?
Yeah, alright. So, this like real redneck boy, he like goes up to college in this big fancy college, and then he comes back to like see his dad for the first time in a year. And he's like, his dad's like, boy, what you learn up in that big fancy school of yours? And he's like, well, Dad, I learned that pi are square. And he's like, boy, you ain't learned nothing. Pi are round. Cornbread are square. See, that got more laughs than yours.
That's pretty good.
See, it was good, wasn't it? My execution was a little off. If you wrote it down, I'm sure people would laugh during your test.
Okay. So anyway, let's break apart this formula for volume.
So much better joker than...
Okay. So this is our formula for volume. Volume is pi r squared dx, or dy. Anyone know the formula for the volume of a cylinder?
It's like 3
Pi r
4
squared times height.
something, I don't know.
Pi r squared h. The formula for the volume of any shape that has a consistent cross section is the area of the cross section times the height. So for a cylinder, the cross section is a circle. So the volume of a cylinder is pi r squared, area of the circle, times the height, right? Pi r squared h. So our formula for our volume of our shapes is pi r squared h. The h is the height, which in our case is the width. And we want those h's to approach 0 so that we can fit infinitely many of them in there and get an exact volume, right? And then of course we do the integral because the integral is an infinite sum of all of those between two limits. Does that make sense? Okay, good. I actually have a great applet to show how it's broken into cylinders. I couldn't find it this morning, so we had to go with the other one instead, which isn't as good, but that's okay. All right, so here we go. What is the radius? The radius is top minus bottom, if you're differentiating with respect to x, or right minus left if you're integrating with respect to y. This is the same as it was for area, right? So your area, the integrand was top minus bottom for dx, right minus left for dy. Here's the difference. For area, you can pick if you want to do dx or dy. It's your call. You're not really like forced into either one. For volume, you're forced. You don't get a choice. So for volume, if the axis of revolution is horizontal, you have to integrate with respect to x. And if the axis of revolution is vertical, you have to integrate with respect to y.
So you would have to like change the equations.
Yes.
I don't really see how you do it with respect to x if it's rotated around the y-axis.
Exactly.
Wouldn't you get the same answer if you treated your y as if it was x?
You would, but you're still going to have to manipulate all your functions.
Like is to
Okay.
I'll show you visually. I'll show you what I'm talking about, okay? All right, so let's get into our first example of the day,
Ooh, conveniently already.
which is conveniently already written, yes, so I don't have to write it twice. And you know what? I'm going to keep it up for fifth so I don't have to write it a third time.
transfer.
All right, so find the volume of the solid formed by rotating. Sometimes they say revolving, sometimes they say rotating. You just have to go with it. Rotating the graph of y equals the square root of x about the x-axis from x equals 0 to x equals 4.
Can we just like calm down a bit for a second? Thanks, Ms. Price. Ms. Price, did you see Zach's belt?
Zach's belt?
Sax. Sorry.
Sax?
Sax. Belt.
You don't know who Sack is?
That's Sack.
Oh, I would never have
Well, my
known
last
to
name's
call him.
Sacolars.
Yes, I get that, I get that.
Well,
Okay.
check
Draw
out his
something,
belt.
Sack
It's
had the
really
word
cool.
sack,
Right,
and then he
see?
drew
Stand up,
Sack.
Sack.
and I was
Belt.
like, oh, this is
Show.
so
Show.
bad.
United States flags.
You have to show it to her.
Nice.
You can't just like.
Maybe
display
just like
it. It doesn't give the same amount of like.
What's the bell ring?
Satisfaction.
I love that game, but everyone's already in it.
Download it. People are playing it.
It's a pretty cool belt.
I want to
That's
my
awesome.
friends now, but it didn't come
All right.
And then
I like hanging this.
I'm kind of obsessed with it right now.
Now, we're gonna draw a picture. You don't have to draw the picture three-dimensionally. As a matter of fact, you shouldn't, because when you try to draw it in 3 dimensions, it adds confusion to the problem that's unnecessary. So here's what you draw for this problem. Technically, you don't have to draw anything, but we're gonna draw it just so we can see visually what's going on. So, first thing we have is we have y equals the square root of x.
Fancy.
So there's our square root function. We're going from 0 to 4. And then you don't have to shade, I'm just going to shade the region that we're revolving.
What if we revolved everything but that? Then we just
That
do
would be
infinity
really crazy.
minus that.
Yeah. Okay,
Still be infinity.
which would still be infinity. Alright, so
Really easy.
if you can imagine the shape three-dimensionally, that's great. Not everyone will be able to. How many of you can visualize what it's going to look like if it's revolved?
It's good dome.
How many of you, like, true, don't be afraid, you're not on camera. How many of you can't visualize what it looks like?
Just Elizabeth Davis.
Oh,
And
what
Morgan
are
Freeman.
you doing?
I didn't promise they wouldn't be on video.
So anyway,
true.
here's what happens. Your brain, being able to visualize abstract concepts in 3 dimensions is one of the last things your brain develops. So,
Are you calling
Why is
people
it so
slow?
funny?
You're ruining her. Elizabeth's a type A personality. She'll get very upset. Yeah, she's a type A
so
personality.
most people don't develop that ability until their late teens to early 20s. So if you can't visualize it today, that doesn't mean there's anything wrong. If you want to wait until you're in your 20s and go back and do volume problems, you'll be able to visualize them like that.
I'll probably be done with them by May.
I was kind of.
You think?
Yeah.
You never know. You never know, right?
I was kind of.
Okay.
How to do it.
Quiet please. For those of you who can picture it, and I'm gonna, just for fun, if you want to, the easiest way to picture this, right, that's what it would look like. Anyone know what, you can tell me what that kind of is.
Like an eye.
Looks like a beanie hat.
Okay, a beanie hat, that's a new one.
A dome.
A dome, right?
So it's
Half
not
a
a dome.
football,
It's not a dome. It's
right?
Half of an eyeball.
I gotta tell you, my favorite one for this is a ham.
Oh,
Right?
that's what
There's
it
no like though.
Yeah, no, but it's like a spiral.
Perhaps
The
Okay.
yarmulke function.
So anyway, alright, so we got our shape. That's what we're finding the volume of, is that shape. But all you need to draw on your paper is this to get the problem correct.
I'm a teacher, I'm
So-
gonna wear gloves so that I can erase the board better.
Like, just eraser gloves, like.
Eraser gloves?
Yeah, just like covered in like the fuzzy stuff.
Okay, so here's what we get. So our volume is gonna be, most important thing to write is pi. Don't forget the pi, right? Don't forget the pi.
What about cake?
Pi is important for this one.
Okay.
Okay, we're going with pi. So, what are the limits going to be for this? 0 to 4. Okay, now we've got to figure out top minus bottom.
Okay.
And so that's our radius. So, top minus bottom, the top is the upper boundary of the shaded region, which is the function y equals root x. The bottom is the lower boundary of the shaded region, which in this problem is y equals 0. So top is very rarely a constant. It's usually a function. Unless it's a horizontal line, then it's a constant. Apart from that, it's going to be a function with x's. So for this one, your radius would be root x minus 0, and you don't have to write the minus 0. Okay,
And then dx.
squared.
DX.
The most common mistake that people make is forgetting to square the radius. So try to say to yourself when you're doing these problems, pi r squared. Pi r squared. All right?
So you forget something.
Now, is our axis horizontal or vertical?
Obviously.
It's horizontal, right? So this is a dx problem. That's kind of an important thing to ask before you start. Does that make sense? For all of these problems, henceforth, I want you to do these on your calculator. So if you have a calculator handy, get it out. If you want to borrow one, feel free to borrow one. But I want you guys to put this in your calculator and see what you get for your answer. While you're doing that, I'm going to plug in the camera.
I was trying to give it back to you, but
Alright, you can think about it.
Actually, sounded like a month ago.
Can you use the,
Actually, it's my car.
the other
You
one?
want it back? I'll give it to you.
The sign?
Probably.
No, you need a graphing to do integrals.
It has your name on it. Just your name and your Wait. Float me. Jen, how highly does.
I think you give us 2 reasons.
Alright, everybody an answer? Anyone need, do you guys need a review on how to enter it? Yes? Okay. Guys, several people in my first period are using the fn_int function. I tend to shy away from that. I much prefer using the graph window for my integrals. So I'm just going to kind of do this on top of the writing here. Alright, so... Okay, oh look at that, I still have it in from this morning. So you put your function, pi times the square root of x squared. Most common thing to forget. People will put it on their paper but forget to put it in the calculator. You've got to remember to square your radius.
It's a second up.
Okay?
No, where's X again? And then you graph it and integrate it.
Alright. Everyone got it? Then you graph. If you don't know how to graph, the easiest way to get your window set is to just do Zoom 6, and that'll just set it to a standard window. And then, by the way, what is the square root of x squared? It's x, right? Okay. So here we go. We go to calc. So you do second trace. That takes you to your calc menu. You can hit 7 or arrow down to option 7 for integral. What's our lower limit? What's our upper limit?
4.
Okay. There are 3 answers that would be accepted for this problem. The first answer, if you did the problem, if you didn't put the pi in, your calculator would just give you 8, but then you can put the pi on yourself. So if you wrote 8 pi, that's fine, right? Or you could give 25.132, or you could give 25.133. They'll accept the truncated or the rounded answer. You can round up or down.
I got 25.
Which one do you recommend doing? Just like that.
Oh, fine.
How do you get the?
Tell me your question.
Never mind, I got it.
I got exactly 25.
That is a problem.
Yeah.
Yeah, it's not-
You know what? And I gotta tell you, mine only gave me 4, and that's because my mode was set to float 4.
Yeah, that's
You
what
might
mine was
want to
on.
make sure your mode is set to float,
Okay.
and that way,
Alright, no, it was on 4, then changed it to 0.
yeah.
Thanks.
Guys, if you're borrowing a calculator, my AMDM kids are doing this exercise, this thing with this program in the calculator, and the float has to be set to 4, so you need to make sure it's set back to float.
How do you change it back to?
Huh?
How do you change it back to normal again?
Just hit mode.
Alright, now I got it.
Yeah. Put it on float.
What if I just like,
You're good there.
and then, ready?
Ooh, that was some pretty fast reflex.
Okay, so if we do it now I get all the decimals.
It's a big thing in Kansas.
Good, everyone okay?
Not sure.
Any questions on that one?
Like you said.
Good, let's move on to a slightly different one. By the way, that is all I expect you to show me on your quiz and your test, is the setup and the answer. Okay, and that's all that's graded on the AP exam, is setup and answer. Yes?
If you were to use like the summation button, could you do the same thing as intervals or like sums? Like
But the summation button isn't going to give you an infinite sum, right? What are you, tell me what you're
if you
thinking.
were, if you were to
Like the sigma you're talking about?
yeah.
But see, that would be an approximation, not the exact. The integral is the only one that will give you the limit as the number approaches infinity, right?
Okay.
I guess if you did this, did the full limit formula, can you do a limit of a sum on your calculator?
Yeah. Well, I was able to also do the integral of the sum on this one.
Oh, does that have integrals on
Yeah,
it?
you used to do second and then integral and then you can enter in the.
Wow, those are nice. Okay, well, good. I wouldn't be too dependent on that though, because you can't graph on
Yeah,
that.
but with this one, if you wanted the sum like sum sum, you like put the limit of an infinite sum and then.
Why would you do that? I mean, honestly, like, let's just stick with integrals. Okay.
I was decent in that.
Okay, so anyway, we'll look at it after, but there's no reason that you would want to try to put your integrals in as limits of infinite sums when you can just do the integral, right?
That's cool. Look at this.
Okay. Okay, so here we go. Find the volume of the solid created by revolving y equals 1/2 x about the y-axis from y equals 0 to y equals 4. You don't have to have a picture, but a picture helps. Y equals 1/2 x is a line with a slope of a half, kind of like that. We are revolving this about the y-axis, so our axis is actually this line right here. And we're going from y equals 0 to y equals 4. So this is the region that we are revolving, and we're revolving it about the y-axis. Is the y-axis vertical or horizontal?
Vertical.
In this case,
It's vertical.
It's vertical. Y-axis is vertical.
How do we know how far right to go?
Wherever 4 hits the
Oh, okay.
function. Okay. So we're going to revolve this way. What shape does that make? Well, that's a triangle, good, but when you revolve it, makes a cone, right? An
It's a
inverted
really
cone?
weird cone.
Very, yeah, flat, wide, upside down cone. Okay, so there's our shape. Since we have a vertical axis of rotation, we have to integrate with respect to y. So when we integrate with respect to y, so we have volume equals, it's still going to be pi integral of something squared dy. All right, first the limits have to be y values. What are the limits? 0 to 4, they're given. But since it's a dy problem, our radius is not top minus bottom, it's right minus left. And when it's right minus left, if this is normally the function y equals 1/2 x, we have to solve this for x in terms of y. So instead, we now have x equals 2y. This vertical line, the y-axis, is actually the line x equals 0. So our radius is 2y minus 0.
Wait, where's the 0 come from? I'm sorry.
Right minus left. The
Okay.
left bound is the y-axis, which is 0. Any questions on the setup? The setup is the most important part, right? If it's a 5-point problem, 4 points are the setup and 1 point is the answer. Yes?
So you couldn't plug in 1/2 x and 4 for that?
If you did 1/2 x here, what's the point?
Like 1/2 x would be your.
Oh, okay, here's the thing, guys. If you take 1/2 x and revolve it about the line y equals 4, is your volume going to be the same as if you take this 1/2 x and revolve it about the y-axis? Is the shape the same? No. Is the volume the same? No. It's a much smaller volume if you revolve about the line y equals 4 than if you revolve about the y-axis. Much bigger volume. So it's not the same. You can't just swap them out because you don't like it. You're stuck. When you have a vertical axis, guys, you're in dy world. There's no way of getting around it.
So not the same as,
Okay?
wait, are those things?
Okay, so answers. So the actual exact answer is 256 pi thirds. I don't know if anyone got the exact answer. Or if you wrote 85.333 pi, that would be correct. But what I'm expecting most of you to have is 268.082 or 268.083. Any of these answers would be accepted.
God, best.
Okay, does that make sense? Are there any questions on how to get the answers? Everyone putting them in okay? You got half that? Did you use the limits 0 to 4? Did you square it? Did you write it in your calculator as 2y squared and not 2y squared?
Oh, yep.
There it is. Okay. Guys, make sure when you square the radius, that radius has to go in parentheses, otherwise it's only going to square the last part of it, not the whole thing. Okay.
Yeah, that's something.
All right, last example. The axis of rotation does not have to be the x or y axis. They can have the axis of rotation be any line they want. It'll always be vertical or horizontal. They're not going to revolve about some diagonal line somewhere. So let's do one that's revolving about a different line. So suppose we said, find the volume of the solid created, or solid, let's say solid formed.
Solid.
By revolving f of x equals 2 minus x squared about the line y equals 1.
Ooh. Fancy.
Give you a moment to write, and then I have $1 million question.
Ooh. Hey, you want to hear something really interesting?
Sure.
You know how on like Who Wants to Be a Millionaire, how when you say ask the audience normally tries to give you the correct answer? Well, in Russia, if you ask the audience, they normally try to give you the wrong answer because they don't think you deserve getting like rich off the backs of like other people. And then in France, it's funny, they only give you the answer if it's a hard question, but if it's a really easy question, then they give you the wrong answer on purpose because they think you don't deserve the money. Sociological trends. Who Wants to Be a Millionaire?
But in the United States, they always just give the right answer?
Yeah. Because we have like the American dream and like going rags to riches. We like that stuff.
You know they usually don't.
Yeah, even though they don't even win
Did
it.
you know the first guy that won it never used the ball line until the very end? They called his dad and said that he's going to go.
Yeah, that guy was awesome. Have you ever seen that guy?
What guy?
The guy that like the first guy to ever win. Yeah, that was
Yeah,
awesome.
he didn't use a lifeline until the very end, then he called his dad to tell him that he was going to win $1 million.
Wow.
Yeah, he was just like, Dad, I'd just like to tell you I want to. And then he got back on it again for it was like people that had gone really far, but he didn't even get nearly as far. He got like I think it was like 100,000.
Okay, so here we go. Here's the $1 million question of the day. Is y equals 1 a horizontal or vertical line?
Horizontal.
And there's no such thing as vertical, right?
If it was x equals 1, then it would be vertical.
If you don't know the answer to this, you've got to learn this or you will never pass the test. Y equals 1 is a horizontal line. Okay? If you're ever in doubt, quiet please. If you're ever in doubt, think to yourself of all the points where y is 1. So if you just plot a little graph, make yourself a little side graph and say, all right, I'm going to plot, 1, 1, 2, 1, 3, 1, 5, 1, 8, 1, negative 1, 1, right? All of those have a y value of 1, and they all fall on the horizontal line y equals 1 because that's where the y values are all 1. Okay? Y equals number is a horizontal line, x equals number is a vertical line. We have a horizontal axis of rotation, which means we are going to integrate with respect to x. All right, so here we go. We've got 2 minus x squared. 2 minus x squared is, it's an upside down parabola that's been shifted up 2 places. So you get something like that. Y equals 1 is a horizontal line, that 1. That's our region that we're revolving. with respect to x, I'm gonna go ahead and label. This is y equals 2 minus x squared. The bottom is y equals 1.
Awkward.
Your son just got ISS. I'm calling it. ISS for kicking the teacher.
Okay, listen. So here we go. So our volume is pi integral something squared dx.
We have
They
to
didn't give us limits.
set them equal to each other. Oh, shoot.
Oh, okay. If they don't give you limits, you have to find the limits. So we do 2 minus x squared equals 1.
So x squared minus 2 plus 1.
So x squared equals 1, and x is
Oh, my bad. I'm so stupid.
plus or minus 1.
Ta-da.
I would have figured that out eventually.
Right? So we're going negative 1 to 1. Tell me the radius.
2 minus x squared minus
1 minus x squared.
So
Make-
basically,
negative x squared
negative x
plus
squared plus 1.
Yeah.
Okay, let's just write it out as we see it. So top minus bottom, 2 minus x squared
minus 1.
minus 1. And you're welcome to simplify. You don't have to. You're typing in a calculator anyway. So
Calculator does it for
it's
you.
up to you. Calculator will do it for you.
Calculator does
All right,
it.
everyone type that in. See what you get.
3.5.
I got it.
Yeah, 5.
Go ahead.
It's 8, but-
I bet it's gonna be better than yours. Pretty good. Do you know why?
I got that too, except I-
Because my milkshake brings all the boys to the yard.
You square
They're
this.
like, it's better than yours. Damn right, it's better than yours. I can teach you. But I have to charge my milkshake brings all the boys to the yard, and they're like, it's better than yours.
You got that
It's better
answer.
than yours. I can teach you. But I have to charge. Alright, did you get 3? Oh, okay. 3.35.
I got 3.0.
Boom.
Yeah.
It's
You know what?
3.35.
It's almost like pi.
Okay.
It's a little bit bigger.
I know.
0.067.
This one, 3.352 would not be accepted, right?
Because it doesn't round.
It's 3.3510, so it only rounds down. All right, is everyone comfortable with this? So, good. So today we did volume by disk.